Good afternoon, everybody. This is a rerun of the webinar that took place on December 7th. We had some issues with the recording, so I'm going ahead and recording this offline to share on our website and to forward to any technicians or anybody that wasn't able to make the original webinar. I just want to start off by saying thank you to everybody who did come by for the webinar. I appreciate your time. And it was a pleasure seeing some new names and some new company names out there coming by to learn about gas regulators. My name's Lucas Cox. I've been with Linc Energy Systems for just over 2 years, and I will be running this presentation for you today. Topics we're going to work through today: a basic overlay of who Linc Energy Systems is, where we come from, how we came about, and what we do in the natural gas industry. A basis of function for natural gas regulators and their construction, overpressure protection options and what overpressure protection is, regulator lockup and droop, altitude adjustments for flow equations for a BTU to cubic foot per hour conversion, regulator sizing, and building part numbers, specifically Belgas part numbers. A little bit of background on who Linc Energy Systems is. We've been in the industry for just over 30 years. We're based out of Lakewood, Colorado, just outside of Denver. We've been working in the Rocky Mountain states for about 30 years. We started with Mercury Instruments, which is now owned by Honeywell. We are a stocking distributor for Belgas Regulators. We are a gold level Honeywell channel partner. We sell all their products from measurement, pressure correcting, monitoring, renewable natural gas skids, field instrumentation, so pressure transmitters, temperature transmitters, flame detectors. We do gas analyzation, so BTU analyzers and chromatography, so natural gas chromatographs, specifically the NCAL 3000. We also are the parent company of GPL Odorizers. GPL Odorizers is a manufacturing company for gas odorization pumps. We manufacture custom turnkey odorization skids in-house, specific to the customer's application. We work very closely with our customers. We provide a 24/7 service line. So when we sell a unit, we're always going to be there to help you out, maintain it, troubleshoot it, and work through it and teach you about it. We do full installations, startups, trainings, and so on and so forth. GPL Odorizers has odorizers for low flow, low pressure applications, something you'd see in the renewable natural gas market, all the way through high pressure, high flow applications as well. Who do we do it for? On the regulator side, we work mainly with utility companies, a few big names out here in Colorado, Xcel Energy, Atmos down in Texas and Colorado, Black Hills, Colorado Springs Utilities is one of our large customers here in Colorado, Intermountain Gas, Dominion Energy, New Mexico Gas. Not only do we work with utilities, we do work with smaller municipalities. Also on a daily basis, we do mechanical contractor work. One of our largest customers, RK Mechanical, US Engineering, Colorado Mechanical, Taft Engineering. So working with mechanical contractor and engineering firms to size regulators for their projects and their needs for their specific applications. We also work with supply houses in the area, some of the big names, George T. Sanders, Rampart, Win Nelson, Ferguson, C.D. Jones. We work with them to help their customers find the right regulator for their applications. A big benefit of this for these companies and why they come to us is not only do we provide the product, we provide the regulators, but we provide all of the sizing and all of the expertise in troubleshooting, making sure that they know their customers are going to be safe and install the correct equipment and the correct regulator, have the proper safety equipment on the regulator for their application, so everything is up to code and everything goes smoothly when they go out and install. So moving on to the basis of function of a natural gas regulator. The main purpose of a natural gas regulator is to provide a flow of gas to match demand of downstream equipment while also reducing a high upstream pressure to a steady, constant low stream pressure that the appliances can run off of safely. The main purpose of a regulator We're taking that high pressure, we're cutting it to a low pressure. Now, this is very important. If you did not have a regulator for, say, on your grill, if you prefer a well-done steak that can be finished in 4 minutes with a 4-foot flame on your grill, then don't install a regulator. I would recommend installing a regulator. Don't need to burn any nose hairs off. It's a lot safer that way. Regulator is made up of 3 main devices. You have your restricting device, which is typically an orifice, your sensing device, which is typically a diaphragm, and your loading device is typically a spring, or in a pilot regulator, it is a spring plus gas pressure loaded on top of the diaphragm. Starting off with spring-loaded regulators, these are the most common style of regulators you're going to see out in the field. You can walk outside on the side of your house or side of your building. Most likely you are going to see one of these spring-loaded regulators. These regulators use a spring that is installed on top of the main diaphragm, as you'll see in this photo. Adjusting the spring clockwise applies more pressure on top of the diaphragm, and that will increase your outlet pressure. Adjusting the spring counterclockwise will do the exact opposite, less pressure on top of the diaphragm, less outlet pressure. You can have different spring ranges, so the weaker the spring, that doesn't take as much pressure to compress the spring, is going to lead to a lower outlet pressure. And as you go up to a stiffer spring, you can get a higher outlet pressure range. Depending on the manufacturer and what model you're ordering, these regulators can be configured with or without overpressure protection, typically internal relief. I would say the majority of the time we do sell these with internal relief if they are an outdoor application, to add that extra layer of safety. Blowing that pictorial up right here is a picture of, or a cutaway of a regulator very similar to a Belgas P140. Basis of function. We have our red here, which is our inlet pressure. So this is going to be coming upstream from your pipe. As we come through here, this is the restrictor, typically the orifice. That restricts that pressure to seep into the diaphragm area. This diaphragm area is going to reflect your outlet pressure. And again, your outlet pressure is determined by the amount of pressure you're applying with this spring on top of the diaphragm. As this area gains pressure, it's going to push this diaphragm upwards against that pressure of the spring. Once it gets all the way up, it will push this valve seat onto the orifice. So what you're seeing here is this regulator is in lockup. So there is no gas flowing through the regulator as of right now. This diaphragm is forced all the way up and the regulator is closed. As downstream demand pulls gas, this pressure is going to lessen, causing this diaphragm to fall, and it will add more pressure as it'll lift this valve seat off of the orifice. This happens simultaneously, so it's constantly regulating the pressure that is moving through this regulator. On top of the diaphragm, we just have atmospheric pressure. So this is just open to atmosphere. This is your vent. You wouldn't see this in a pilot regulator, as this would be loaded with gas pressure, and we'll get into that on the next slide. And also, this is where your internal relief plate will lie, and we'll also get into that later in the presentation. Pilot operated regulators. These are a little bit different than the spring operated regulators. You will not just be loading the diaphragm with spring. You'll be loading it with spring, and you'll also have a pilot that is regulating upstream pressure that is also applying force of gas pressure on top of the diaphragm. Now, these are typically used in a constant load application, larger higher flow applications, boilers, furnaces, dryers, larger pieces of equipment, generators and stuff like that. These provide a greater stability in outlet pressure due to a constant and even loading pressure across the diaphragm. You're not just loading it with the spring in the middle, you're loading it with an even pressure across the whole top of the diaphragm. And these typically do have a higher lockup pressure due to the constant loading pressure. They take a little bit longer to close, and we will get into lockup pressure later in this presentation. Pictorial here for a pilot operated regulator. As you can see now, above the diaphragm is not atmospheric pressure. So this typically is the reason why these regulators do not come with an internal relief option. So you would have to add some form of overpressure protection, either a relief valve, putting two regulators in series, an operator monitor, or something of that sort. The reason being is that we have gas loading pressure that we're pulling off the inlet of the regulator, the high pressure side. We're regulating it in the pilot, and that is applying pressure inside of here. You would not be able to do that if you had a vent on this regulator. You would not be able to load pressure with gas on top of the diaphragm. You would only be able to load the spring pressure as seen in the last pictorial. So when we're sizing a regulator, the correct information is key. This is the first questions we will ask a customer when we get a call to size a regulator. This is very important. It's always very imperative to collect the appropriate information prior to sizing a regulator. This will eliminate any issues or faults or potential dangers down the road if you are not gathering all the correct information to properly size a regulator and make sure you have the correct regulator in your application. So gas type, typically natural gas, sometimes propane. Line size isn't super important. Sometimes the line size can be a bit oversized for a customer's application, so we'll actually push down to a smaller regulator. So we're not oversizing the regulator. But typically, we like to gather the line size as a preferred line size of what the customer is looking for, but if we need to adjust accordingly, we will do so. We also need the inlet pressure, so your high pressure side that's going into the regulator, and your outlet pressure, your desired outlet pressure from the regulator that your equipment downstream needs to operate. Typically, you'll find this information in the cut sheets of your appliances. They will say what pressure they need to operate. Typically, it's a pressure range. Most appliances run somewhere around 7 inches of water column to 14 inches of water column. Keep in mind, water column is a measurement of pressure. So there's about 28 inches of water column in 1 psi. We also need to know the downstream demand, so how much energy this regulator needs to flow through it. How much gas do we need to flow through it? Typically, this is in BTUs per hour, and then we would need to convert that into cubic foot per hour. We also want to know whether it's an indoor or an outdoor application. This will determine whether we want a regulator that can be fitted with a vent limiter or not. Is overpressure protection required? Natural gas fuel code states any regulator that has an inlet pressure greater than 2 psi needs to be fitted with overpressure protection. This is a safety piece right here, right? We don't want to be sending high pressure gas into somebody's house or into a building where there's people, or into a school where it's going to be a danger to the public. So we always want to make sure that we have that protection in the event of a regulator failure. We can protect downstream equipment and safety of people in that building with overpressure protection. We also want to factor in altitude, not something you have to worry about at sea level. Up here in Denver, we absolutely have to worry about it being a mile high. We've got a conversion for BTU to cubic foot. Since the air is a bit thinner, there's less atmospheric pressure up here. There's not going to be as many molecules, therefore there's not going to be as many BTUs in our gas, or as much burning power in our gas. So first thing we have to do once we have the BTU load is convert that into cubic foot per hour. Why? The cut sheets for regulators, all the capacity charts are typically listed in cubic feet per hour. So we want to convert our BTU rating to cubic foot per hour. So keep in mind a British thermal unit, or BTU, is a measurement of energy. That is a measurement of how much energy is in that gas. It's defined as the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. So to appropriately size a natural gas regulator, we have to convert this to cubic foot per hour. At sea level, it's typically 1,000 BTUs in 1 cubic foot of gas. Now, as altitude increases, the air gets thinner, less atmospheric pressure. This rating is going to drop. And at a mile high, we use a conversion factor of 830 BTUs per cubic foot. This is very important when sizing a regulator. We will need to pass more gas through the regulator at altitude than we would at sea level to make up for the BTUs. So if we weren't to do this conversion at altitude, we could potentially severely undersize a regulator and not be able to flow enough gas through it properly for our appliances to function. Getting into overpressure protection, there's a few forms of it. Relief can be either internal relief, or we can actually put a relief valve downstream of the regulator on a tee, as you see here. So we have our main regulator, we tee it off to just a relief valve. And that relief valve has a spring in it, similar to a spring-loaded regulator, that you can set to a certain pressure of when you want that valve to open and start relieving gas to protect your downstream from overpressure. You can also do it in series, so a double cut. So you've got a little bit of a backup. If one regulator were to fail, you still have another one in place. You can also do a operator monitor system. They've got wide open or working. So these are both sensing downstream pressure. Typically, your operator is the second in line, and this is handling the main pressure cut in a wide open monitor. In a working monitor, it is a dual cut with the monitor sensing downstream pressure. And if this regulator were to fail, it's going to send high pressure through this sense line, and it's going to actuate this regulator to start picking up and doing the work to protect downstream equipment. The nice thing about an operator monitor is you're not venting to atmosphere, so it is a closed system, but you still have overpressure protection. So internal relief, this is the most common style of relief that we provide with our outdoor regulators. In the event of overpressure, you'll see in this picture, this dictates a piece of debris getting stuck in your valve seat, between your orifice and your valve seat, allowing this regulator to not be able to seal or lock up. So when that happens, all of your inlet pressure, your high pressure side, is able to creep into the regulator. It's going to push this diaphragm all the way up. The regulator is going to try to lock up, but since we have something stuck in here, that is not going to work. So in that event, you'll see there's a smaller spring inside of our main spring. So this main spring, say your set point was 7 inches of water column. There's different relief springs, and we can size them based on what you're looking for. Typically 7 inches or 9 inches of water column above your set point. So once this diaphragm is bottomed out, if pressure continues to rise, it will actually push this spring up, opening a relief plate here, allowing the gas to release through the diaphragm and up and out through the vent. Again, protecting your downstream equipment as a safety factor. Overpressure protecting devices, another form of OPP. This is an OPD, so overpressure protection device. This is a Maxitrol you see pictured here. So similar to the series or the operator monitor, there is two pieces. If this regulator were to fail, we have a backup. We typically see these indoors if they need a vent limiter, if they do not want to vent to atmosphere. So this provides overpressure protection in an application like that. Vent limiting devices. This is something we will use indoors. You will see this vent limiter is this little brass nut here. It's got a small ball inside of it that moves up and down. If this regulator were to fail and start venting gas, it would limit the amount of gas that comes out of the regulator. So these are for indoor applications where if the regulator were to fail, we don't want to be filling the room with gas very quickly. Now, keep in mind with these type of regulators, these line pressure regulators, They do not have internal relief, so they do not have overpressure protection unless you're installing an OPD as seen in the picture before. This right here is a Belgas PG105. So this is a direct crossover from the Maxitrol 325 series. This has been a great line for us to have. We use these all across the Mountain States for our mechanical contractors that are installing these indoors on water heaters and other appliances. Very nice to have the vent limiter so they don't have to pipe the vent to the outdoors. They are CSA ANSI certified line pressure regulators, so they'll be up to code. The great thing about this line that actually released this year with Belgas, it is a relatively new line. With supply chain issues, Maxitrol has had a lot of troubles, and we've had problems keeping them in stock. Belgas has done a great job of having plenty of these on the shelf, and we have plenty of them on our shelf. So we can provide our customers regulators in the same day. If they're close, if they're local in Colorado, if they're a little bit further, you factor in shipping, but we can ship out same day. Now, in the event that you don't have a vent limiter on an indoor application, sometimes you can't have a vent limiter if the inlet pressure is too high, up to code. So we need to put an internal relief style regulator indoors. Now, if that's the case, that regulator cannot vent indoors. So we need to run a pipe from the vent to atmosphere. And there's a couple things we want to keep in mind when we are doing that. One, we want to make sure the vent pipe is never smaller than the vent port on the regulator. Also, if we are running a vent far, more than 10 feet, we want to increase the nominal pipe size for every 10 feet of vent piping. This is because gas naturally wants to expand. So if that pipe is long and we don't expand it, that natural gas will expand inside of that pipe and start applying pressure to the top of our diaphragm, which is then going to fluctuate our outlet pressure, and that diaphragm is going to be bouncing up and down because we're adding pressure other than our spring, which is going to keep our outlet pressure very not constant. And we're looking for a constant outlet pressure. That's the safety, that's the functionality of a gas regulator. We don't want our outlet pressure fluctuating. Supporting the vent pipe is always recommended. That's something just kind of simple, not a huge thing, but if you are running a very long vent line, obviously we want to support it. Always pointing the vent pipe toward the ground using a gooseneck. You don't want the vent pipe pointing up towards the sky when you vent it outside. You're going to get water or debris in your regulator or possibly in your vent line, and it's going to plug your vent line. That will become an issue if your vent line is plugged. As that diaphragm moves up and down as the regulator functions, that air that is above the diaphragm needs somewhere to go. If it doesn't have anywhere to go, as that diaphragm moves up, we're going to increase pressure of the air that is trapped above the diaphragm. That's going to apply force down on the diaphragm, increasing our outlet pressure. As that goes down, we're going to create a little vacuum, and it's just going to keep going back and forth. So it's going to be fluctuating up and down. So we want to make sure that the regulator can breathe, or else it's going to get choked out. And then using a bug screen always to, that prevents debris getting into your vent line. Another big one is if you have multiple regulators inside, so you have a slew of boilers, you got 3 or 4 boilers, you need to run vent lines for all of them. Do not put them into a manifold, or these vent lines can start acting on each other. If you were to have one regulator fail and start venting into that manifold, that gas pressure is going to act upon the other 3 or 4 regulators that are also piped into the same manifold, increasing their outlet pressure, fluctuating, and that regulator is going to start buzzing because that diaphragm's moving up and down rapidly. Getting into some of the technical terms when speaking about regulators. Droop is quite a common one. You're going to see it on all of your capacity charts. So droop is defined as the decrease in outlet pressure below your set point as flow increases towards the maximum capacity of the regulator. Now, droop is going to have the most effect in your last 20% of your maximum capacity of the regulator. So we always like to avoid the last 20%. If your regulator is only rated for 400 cubic foot per hour, we don't want to size it anything above 300 cubic foot per hour, or we're going to start drooping and we're going to lose outlet pressure off of our set point. A great example of droop is to think of a garden hose with a spray nozzle on it. So as you open up that spray nozzle, you're going to realize you reach a point where you have maximum flow with maximum pressure. As you hold that nozzle, you're going to realize that the pressure is going to fall off. So this is very, very similar to the flow of natural gas. So we'll reach that point of maximum flow, maximum pressure. After a while, that pressure is going to fall off, but the flow is going to remain constant. That is droop. So droop is sacrificing pressure to make up for flow. So there is a few typical acceptable droop values, as you see listed here, and those will be in your capacity charts, and we'll see that later when we take a look at the Belgas P212 sizing example. What is lockup? Another term you're going to hear quite a bit. This is a very common one. So lockup is the increase in outlet pressure above set point when the regulator is closed. So as you reach your pressure set point, that diaphragm is going to be forced up and it's going to push this valve seat into the orifice. Now, if you have a set point of 7 inches of water column, it's going to take a second or two for that regulator to actually close. So during that time that diaphragm is moving up and that valve seat's moving towards the orifice, a little bit of extra pressure will creep through. Now this lockup only happens if your downstream demand has been shut off. So you have zero gas being drawn from the end of the pipe. Regulator is letting pressure through, you're reaching your set point, the regulator is about to close, it's going to let a little bit of pressure through before it actually closes. So when it comes to sizing a regulator, we want to factor in droop and lockup. We don't want to set our regulator to a set point that is close to the minimum pressure that your appliance can run off of if we are close to the maximum capacity of that regulator. If it begins to droop, the outlet pressure can drop below what that appliance is requiring to run on. Factoring lockup, we don't want to set our outlet pressure too high to where it's close to the maximum pressure that your appliance allows. So if your appliance only allows a maximum of 10 inches of water column, if we set it at 9 inches or 10 inches, when the regulator locks up, when that appliance shuts off, for instance, a boiler, if a boiler were to shut off, the regulator begins to lock up. We're going to be a little bit higher than our set point. Lockup pressure is typically a couple inches above your set point on lower pressure regulators. That time it takes for the regulator to close once your boiler has shut off is going to let a little bit of pressure through. So if we have it set at 10 inches and our maximum pressure allowed from our appliance is 10 inches, when that appliance shuts off or that boiler shuts off, our lockup pressure is going to creep up to maybe 11 inches or 12 inches. When that boiler goes to start again, it's going to see 11 inches or 12 inches in the line, and it's going to get a high pressure alarm. It's not going to fire up. So we want to stay away from the maximum allowable pressure of our appliance, factoring in lockup. Sizing examples. So this is something we do on a regular basis. These are what we go through on the day-to-day. We get a call from the customer. We gather all the information we need to gather, and we use that information to size a regulator for them. So for this instance, we're going to be taking a look at an application on a 2-inch pipe. We have 3.5 million BTUs per hour that is required for the appliances downstream or appliance downstream, or 3,500 MBH. The MBH just adds another 1,000. That's what the M stands for, is 1,000. Inlet pressure is 2 psi. This is very typical. A lot of utility companies set their meter and regulator sets for 2 psi. Sometimes it can be 14 inches of water column or a half psi, but typically it is 2 psi. Sometimes you'll see it set at the 7 inches, so it's already at low pressure for the customer. But for this instance, we're going to be looking at a 2 psi inlet and a desired outlet pressure of 7 inches of water column, again, roughly a quarter of a psi. This is a very common pressure for most appliances to run off of, at least smaller appliances. Larger boilers may run off a bit of a higher pressure, but this is the most common. Location, Denver, Colorado, 5,280 feet above sea level. So in this scenario, the first thing we need to do is convert our BTU per hour to cubic foot per hour. So in Colorado, we're going to divide our BTUs by 830 BTU per cubic foot. So those BTUs are going to cancel out and we'll get 4,217 cubic foot per hour. Now, if we were to do that at sea level, we'd be looking at 3,500 cubic foot per hour because it's 1 to 1,000. So you can see why this is important. We need almost 700 more cubic foot per hour to make up for this BTU load to get enough gas through the regulator at altitude, again, because the air is thinner. So this is very important for us to factor in, or else we'd be undersizing regulators every day. So taking a look at the next slide, we can utilize a sizing chart of the Belgas P212. And this is a typical pictorial of what most sizing charts will look like. And this is what all the Belgas's charts look like. So we're going to come down to our 2-inch size for the Belgas P212. We'll take a look at our inlet pressure here. We want to be at 2 psi. Our outlet pressure is the 7-inch water column chart with a 1-inch water column droop. Now for this application, we would bring it over at a 2 psi inlet, 7-inch water column outlet, and these are our capacity numbers listed in cubic foot per hour. So the maximum flow of this regulator with the largest orifice is 6,000 cubic foot per hour. So this regulator would work for that 4,200 cubic foot per hour application. Now keep in mind, we could use a smaller orifice, but this is getting close to where we're gonna have droop. At 4,200, this is only rated for 4,500. We're well within that final 20% range of the capacity, so that is not going to hold that 7-inch water column outlet pressure. So for instance, if we were flowing 6,000 cubic foot per hour in this application and we applied this regulator from 2 pounds to 7 inches, if we set our regulator at 7 inches and flowed 6,000 cubic foot per hour through it, we would lose an inch due to droop, so our set point would droop to 6 inches of water column. So we always like to leave ourselves a little bit of buffer to make sure we're not getting heavy droop through the regulator. Another thing to keep in mind, you'll see these squares down here are grayed out. These are the limits for the orifice for inlet pressure. So the 1 3/16 orifice is only rated for 13 psi. The 1 inch is rated for 25 psi, so on and so forth. Now, typically, we don't like to butt up right against this line. So if we have an application that is for, say, 25 psi, we wouldn't want to use that 1 inch orifice. Yes, it's rated for up to 25, but typically if you have an inlet pressure of 25 psi, there is a chance that that can fluctuate and get a little bit higher than your 25 psi, and then you're over the limit for that orifice can handle. So we would size down to a 3/4 inch orifice if we were at 25 psi. This one's rated to 60, leaves us a little bit of room for breathing. Okay, so now we've figured out our regulator. We figured out which regulator we want to use based on the inlet pressure, outlet pressure. It was an outdoor regulator, and we sized it on the BTU load and converted that into cubic foot per hour. So Belgas has a really nice way to develop your part numbers. A lot of other companies don't have something like this, so you're going to be ordering a regulator and then typing in your specs, what orifice you need, what spring you need. Belgas has a very clean way of doing this, that you develop your whole part number very specific to what you're looking for. So the way it works is always going to start with the model number of the regulator, as we'll see here, P212. Moving down, we want to use the normal configuration. We would use the high configuration if our outlet pressure was greater than 1 psi. You'll see here all of these springs in the water column range are for the low pressure versions. And these higher pressure springs are for the high pressure version of this regulator. For this application, obviously we're going to be looking at the low pressure normal configuration. So we are looking for a 7-inch water column outlet. So pipe size, we've got our 2-inch NPT pipe. We have a 6 to 14-inch water column spring that will allow us to set the regulator to 7 inches. Yes, we could use the 5 to 9-inch spring, I'd say it's always nice to have a larger range, just in case you do replace appliances or something changes or you need to account for a little bit of droop. You have a little bit more range to work with. Special construction, none here. We're just looking for NPT. We're not going to be doing the flanges. Our orifice choice, we chose the 1 3/16 inch. If we can use the larger orifice, if we don't have that high of a inlet pressure, typically go with the larger orifice, get a little bit more breathing room with our capacity, and avoid that 20% area where we're going to droop. Port orientation, we go with up as standard. This one's not too important as it is very easily field switchable. It's 2 bolts on the regulator flow body. You can take off, rotate them 90 degrees, 90-degree increments in a 360-degree rotation. So we can use this so that we make sure when we're installing the regulator, whether it's on a horizontal pipe or a vertical pipe, we want to make sure our port is in the position that when we install the regulator, for one, the flow is going the correct way. Two, we want to make sure that the vent is either pointing towards the ground or pointing towards perpendicular to the ground. We don't want the vent pointing towards the sky. We're going to get water in there. Out in Colorado, we'll get plenty of snow and ice, and that will wreak havoc on the function of the regulator, as well as possible debris. The bonnet orientation is something you want to pay attention to before ordering. Not as easily field switchable as you have to take apart the whole regulator and hope you get a good seal on the diaphragm again. So we always want to make sure that we get the right bonnet orientation. 3 o'clock is the standard with the up port orientation. Typically that's going to allow you to configure your regulator to not have the vent pointing towards the sky. But as long as we can switch around that port, we should be able to find a way to get that vent pointing downwards. Material option, we're just doing the standard iron for this. So building our part number, as we choose everything here, you'll see the corresponding part number pieces here. So we build it on P212, L16, 014, so on and so forth. So you have very specific part number that's going to tell the factory what you are looking for in your regulator. So there's zero confusion. So you'll always get what you're looking for as long as we go through this and do it the proper way. Common troubleshooting. This is a big one. We work with our customers every day on this. Regulators do have issues. There's multiple reasons for those issues, but typically they can be remedied, taking a look at the symptoms and diagnosing what we need to do to fix it. One of the most common ones is gas is constantly relieving out of the vent. So we'll get customers a call and say, my regulator is broken, it's not working, it's constantly venting, it's leaking, I think I either blew the diaphragm. If we're looking at an internal relief regulator, 99% of the time, if we're venting gas, we have something stuck in between the orifice and the valve seat, as we saw in this photo earlier. So as that piece of debris is stuck in there, the regulator can't close. So we're going to be adding more pressure than our desired outlet pressure here, causing that relief spring to open up and vent gas out of the regulator. It could be something like pipe tape, pipe shavings, dirt, if the pipe's been sitting on the site for a few days before it was installed. There could have been too much pipe dope used when installing the regulator and you get a glob of that stuck on your valve seat. We've seen all sorts of stuff. Everything from what we're seeing here to a beer can. We have found a beer can inside of a regulator. Not exactly sure how that happened, but I wouldn't recommend drinking and working on a gas pipeline. So solution, open up the regulator. Typically, it's just those 2 bolts off of the body of the regulator. Open that up and you will be able to see the orifice and the valve seat and clean out any debris that might be stuck in between them. Now we also want to check if we did get a piece of pipe shaving in there and the regulator closed on it, we want to make sure it didn't damage the valve seat. So that rubber valve seat, that flat piece of rubber that butts up against the orifice, if that were to be damaged or have an indent or a scratch in it, there is a possibility that a little bit of pressure could get by. Another common issue, a buzzing sound in the diaphragm. Typically, this could be the inlet pressure is too high for the sized orifice. It is also a possibility that we have an issue in our vent line. We'll get to that at the bottom here. Solution, referring to capacity charts as we looked at there, make sure our inlet pressure is not in that grayed out area. It's always a good idea to put a gauge upstream of your regulator before installing. Sometimes you will get an answer from the utility of, hey, it's 2 psi or it's 5 psi, and sometimes it could be a little bit higher. So it's always good to verify that and see what is actually in the pipe. Solution is obviously getting the right orifice in that regulator. And the orifices in the spring-loaded regulators are pretty easy to change out, right? It's those 2 bolts to take the valve body off and then take the orifice out, put in a new one. Another common issue, outlet pressure is much lower than set point. This typically means the regulator is undersized, so we are drooping. Another common issue, outlet pressure is much lower than set point. Typically, this means the regulator is undersized and we are drooping. So we want to avoid, again, staying away from that final 20% of the regulator's capacity so that we're not compensating or losing pressure to make up for flow. Solution, verifying our capacity charts, getting the right regulator in there. Another issue, outlet pressure is fluctuating or pulsing. We will typically see this when there is a vent line issue. If that vent line is plugged or it's not big enough, that diaphragm is going to be moving up and down because we are adding force of pressure above the diaphragm other than our spring. So a good way to troubleshoot this, if you're having pulsing issues with a regulator, remove your vent line. If you remove your vent line and that issue is resolved, then there's a problem with your vent line. That's an easy way to tell. This could also mean the regulator is largely oversized, so not enough gas flow through it, that regulator is too big. It's almost stalling out, right? It's not running at the speed it needs to be running. It's not running at the load it needs to be running at. So it's constantly opening and closing to let a little bit of pressure through, but it's not enough for the regulator to really function. This leads to a topic called turn down ratio. Very similar to gas meters having a turn down ratio, so do regulators. So typically we see it at 100-to-1, right? So if the regulator is rated for a high end of 100 cubic foot per hour with 100-to-1 turn down ratio, the lowest that regulator could function at is 1 cubic foot per hour. Now there's no regulators that are only rated for 100 and 1 on the low side, but that is the equation for it. So you would take your maximum capacity and divide that by 100, and that would be your minimum capacity. You want to make sure we're not below our minimum, or else we would be oversizing the regulator. So that concludes the training portion of this presentation. We'll go ahead and move on to a little bit of Belgas's product offerings and a little bit of history on Belgas. As always, feel free to contact me directly here at my email if you have any questions or you have any inquiries for regulators or issues with your regulators. Feel free to reach out. We're here to help. We love to meet new people. We love to have new customers. Give us a call and let us help them out. Okay, moving on to the Belgas product portion of this presentation. We'll kind of breeze through this a little bit because a lot of the stuff we have already covered, but we'll take a look at the regulators that Belgas has to offer. So Marsh Belafram has been around for quite some time. They have 14 divisions running across various aspects of the oil and gas industry. In 1995, Marsh Belafram was established through the combination of 2 companies. So Marsh Instruments, which was established in 1865, and Belafram Diaphragm, which was established in 1950. So they've been around about 3 times as long as I've been around. Belgas is a division of Marsh Belafram, and mainly we'll be focusing on the Belgas division, but there's many other divisions across their platform for all sorts of offerings in the natural gas industry. They're based out of Pittsburgh, and they've got a 215,000 square foot facility where they stock plenty of regulators and have their whole engineering team. It is a state-of-the-art facility. It is really impressive. Keep in mind, all of their products are ANSI B109.4 and Z21.8 compliant. Very important thing in this industry. Always want to make sure we're we've got our specs right, that we're speccing in a regulator that is built to the safety standards that have been put in place across the US. So here's companies at a glance. Again, we'll be focusing mainly on the Belgas division. Linc Energy also utilizes Marsh instruments in our odorizers, in the GPL odorizers line. So we are using their gauges. We actually are also working on designing a custom regulator manifold with their engineers over there to provide a pressure cut from the high pressure side of the odorizer. We can use that higher pressure cut to charge our odorant vessel with a blanket gas, utilizing pipeline gas. So this has been a great resource for us. Not only do we sell Marsh Bellofram's products to our customers, we are also a customer of Marsh Bellofram and Belgas. We use their instruments and their regulators in our odorizers. In the odorization world, safety is very important. Mercaptan is very volatile, very smelly, and things can go bad really fast. So we only use products that we know we can trust and that will provide us tip-top performance. And it's been great to be able to custom design to our specs as we build all of our odorizers custom for each application that we provide to our customers. It's great to have a resource like Belgas and the engineers they have there to design us custom pieces for our odorization packages. You can find Belgas in various markets. There's a few of them listed here. Again, we're focusing on the natural gas market. Belgas manufactures pressure reducing and pressure relieving regulators, both direct and indirect operating, along with instrument supply, slam shut regulators within residential, commercial, industrial, HVAC, plumbing, boiler applications. At Belgas, they hold 100% testing along with their quality assurance packages. So everything is tested before it leaves the warehouse, before it leaves the factory, so that you are not going to get a faulty regulator. So moving on to some of the most popular residential and service regulators that Belgas offers, and by far the most popular regulator that we sell. Looking at the P140, this may look pretty familiar. It's very similar to an Itron B42, the Honeywell SR113, Census 496, and I believe Fisher has a model like this as well. So your standard small residential natural gas regulator. P143 is very similar, something you would see from Itron B31, Honeywell 1813C, or the Census 143. A little bit larger than the P140, same basis of function, a little bit more capacity range. So diving a little deeper into each one of these regulators, the P140 can be spec'd out with relieving or non-relieving. They do straight bodies, angle bodies, and again, ANSI B109.4 compliant. Coming soon, they do have a half-inch model. So once this is released, they will have half-inch, 3/4, 1-inch, and 1.25 inch. P143 being the full-size residential or small commercial regulator. Rugged construction. This is, again, a little bit more capacity than the P140. Same function, available in 3/4 inch, 1-inch, 1.25 inch. Outlet pressure can go up to 6 psi. The P140 can go up to 5 psi. They are working on an angle body configuration for this regulator as well. Belgas offers several products that can be used in commercial applications. Base platform of the P200 series with a 14-inch diaphragm and the P300 series with a 7-inch diaphragm. Now, generally speaking, the larger the diaphragm, the greater the accuracy due to that pressure being spread across a larger surface. Gives the diaphragm a higher resolution in its sensing ability. Again, they have relieving options, non-relieving options. They also have pilot options, slam shut options that you will see here, and an enhanced relief option that you will see in the P212. So it's got an enhanced relief curve. It can relieve more pressure, more gas. A P200 and P300 series are something we do quite often as well. We use these on larger capacity applications, something you'd see on a boiler, a large generator. We typically use the P212 because it has that enhanced relief, an extra added layer of safety. We can do internal or external registration, relieving or non-relieving, and they also have pilot operated options. P300 is a bit smaller, something similar to an Itron B34SR, that middle ground between the 143 and the larger P200. So it's kind of the middle ground regulator to cover that range between 1,000 cubic foot per hour and then upwards of 2,000 cubic foot per hour, where you don't want to do overkill with a big P200, or something like an Itron B34 or B38. The P200 and P212 would be a bit overkill for something that a P143 just barely couldn't handle. So it gives us that middle ground to kind of give us a little bit of leeway to use a mid-sized regulator instead of upsizing to a larger commercial regulator. Belgas also offers the P133 commercial regulator, which is a direct operated pressure reducing regulator with internal or external pressure registration. This is used in commercial and industrial applications, especially when the downstream supply is sensitive and accuracy is critical. That is the benefit of having this sense line here in the 133. They do have a new version of this, the P134, that has this sense line internally, so saves a step on installation. You don't have to pipe it downstream. The regulator has a balanced diaphragm design, which minimizes the effect of supply pressure variation on output pressure. This regulator has one of the largest flow capacities in their commercial regulator line, and outlet pressures ranging from 2 inches of water column all the way up to 10 psi. And the P133K here is for higher pressure applications with outlet pressures ranging from 2 all the way up to 60 psi with 7 different spring ranges. Belgas does have options for integrated monitor regulators or operator monitor setups made up of 2 regulators where the primary regulator is working and the secondary regulator is monitoring, serves as a backup if the primary regulator fails. And the P203 and the P303 are the most common regulators we would use in this setup. Typically not something you're going to see on the side of a house, something you're going to see at a gate station before distribution to the customers. Here are a few of their pilot operated regulator options. A great benefit of these pilot regulators is they do minimize droop and they provide a much more stable outlet pressure. So for high demand or very finicky applications where larger appliances, industrial appliances need a very steady delivery of gas at a high capacity, the pilot option is the way to go. Belgas also offers farm tap regulators. So this is something you're going to see as a first stage regulator at a gate station. So we're cutting a very high pressure to a medium to high pressure on the outlet. They can range up to 500 psi on the outlet and as low as 3 psi. So typically something you're going to see as a very first cut, before it's distributed to customers. Here's a few of their instrument regulators. I won't go too in-depth on this. The P39 is the piece I spoke about earlier that we are utilizing in our GPL odorizer systems in a dual cut custom manifold series. They have a large offering of back pressure regulators and relief valves. So if your regulator does not have internal relief and your inlet pressure is greater than 2 psi, we can utilize these relief valves to provide overpressure protection for downstream. Most common one we use here is the P289. We do use the P1808 in larger industrial applications where we need a large amount of relief for added safety. Another great offering from Belgas is slam shut safety regulators. So in the event of overpressure, instead of just venting the gas to atmosphere to get rid of that extra pressure downstream, the slam shut will actually close the regulator and stop the supply of gas. So again, an extra added layer of safety here. Instead of just venting, we're actually going to turn it off. Here's a cool little pictorial of an overpressure event and how the slam shut device closes the regulator. As the increase of outlet pressure acts against the larger spring and pushes the diaphragm assembly up, this disengages the spring loaded stem of the slam shut. Now, when this occurs, we will stop all flow downstream, and it has to be manually reset. The P100SX slam shut regulator is a pretty cool piece of equipment. Belgas is actually working on developing a thermal shutoff for these regulators. This was something that was very interesting to us in Colorado, as wildfires are very prominent here and quite scary. We had one last year up in Boulder that flattened about 1,000 homes in a day, 100-mile-per-hour winds, and the utility companies were running around like crazy trying to shut off all their gas lines. The cool thing about this is it has a temperature sensor. So if it were to sense an extreme amount of heat, it will actually close the regulator right then and there automatically. Saves a lot of trucks running around trying to get it, and it does it faster, it's safer. In the event of a wildfire, obviously we don't want to be pumping natural gas into it. That would be fueling the fire, and it would only make things worse. So here's a little description of how the P100SX operates. The OPSO will trip once the downstream pressure is high enough to lift the OPSO diaphragm and trigger the shutoff mechanism. Now, this set point for the OPSO is adjustable. So it is spring-based, so we can adjust that range of where we want this regulator to shut off if pressure reaches a certain threshold. Here is the governor line from Belgas, as we spoke about earlier. They do have options for inlet ranges from 2 psi or 5 psi. Again, they're working on developing an OPD or overpressure device for those 5 psi applications. A few companion products to take a look at. I won't go too in depth on this. To close things out, why choose Belgas? 100% individually tested high quality products. They've got a stable and reliable supply chain. As everybody knows, it's been a rough 2 years for supply chain. Belgas has been very stable and steady in getting us regulators on time, keeping regulators in stock, and being very upfront with their lead times. In the event of a long lead time, we will know ahead of time and it will be accurate. Belgas also has a lot of great people over there. Our channel manager, Rich Riato, is very easy to work with, very communicative, and if you have any questions, you can go straight to him. If he doesn't know the answer, he will get you in contact with one of their engineers who does. And there's plenty of people at Belgas that have knowledge across many different product lines. Here are a few links to a few informative videos if that does interest you to go take a look at. A little bit of info on their quality assurance packages. And here is their website where you can find your part number, download documents, and watch educational videos. Or even you can go on there and request a quote, and that quote will be, or that request for quote will be sent to whoever handles the territory you are located in. And that will conclude this presentation. Again, I appreciate everybody taking time out of their day to come learn about regulators with me. If you have any questions, please feel free to reach out to me directly. There's also the contact here for the National Sales Manager and Regional Sales Manager for Belgas. But thank you all again, and I hope you have a wonderful day.